Question number 1. The equation of a line is 3y plus 4x equals 12. The gradient of a line perpendicular to it is, and then we're given a choice of 4. So what we should remember from before is when we have the straight line in the form y equals mx plus c, we can quite clearly read off the gradient m. Now, the problem with our equation up at the top is it's not in this form, plus the fact we're trying to find the gradient of a line perpendicular to that. So first things first, we need to rearrange the equation we are given into the form we have here in blue. So we have 3y plus 4x equals 12. If we move the 4x onto the other side, that becomes negative 4x plus 12. We need y equals, so that means we need to divide by 3, which gives us negative 4x plus 12 over 3, which then gives us y equals negative 4 thirds x plus 12 divided by 3, which is 4. So that means the gradient of the line given is negative 4 thirds. So we'll write that down as m1. So we're looking for a line perpendicular to that one, which means we flip this one upside down and change the sign, which means the gradient of the perpendicular line is 3/4, and that corresponds to answer C. Question number 2. Two functions f and g are defined on suitable domains as f of x equals 2 over x and g of x equals x squared plus 3. We're then asked to find the value of g of f of 1/2. So that's a composite function where the f function has been substituted into the g function, but also 1/2 has been substituted into the f function. So we'll take care of the f of 1/2 first of all, so we'll give ourselves a little bit of room. So the original f function is f of x equals 2 over x. We are trying to first of all calculate f of 1/2, which means it's 2 over 1/2. That means 2 divided by 1/2, so we can write it that way, 2 divided by 1/2, and we can calculate this by changing it to a multiply and flipping the fraction upside down. 2 times 2 over 1 gives us 4 over 1, which is equal to 4. What we need to do next is substitute the f of 1/2 into g of x. So the first thing we'll do is write down what our g of x function is. G of x is equal to x squared plus 3. Now, we're actually asked to find g of f of 1/2, but we have since worked out that f of 1/2 is 4, so that means what we're trying to actually work out is g of 4. So if we substitute that in, 4 into our g function, we have, instead of x squared, 4 squared plus 3, which is 16 plus 3, and 16 plus 3 is equal to 19. So our composite function equals 19, and that corresponds to one of the answers on our original question, which was answer A. Question 3. The gradient of the tangent to the curve y equals 2x cubed plus 3 at the point 2, 3 is, and then we're given 4 choices. So as soon as we see gradient of tangent, we should recognise that what we need to do here is differentiate. So we'll write down the curve that we have to begin with, which is y equals 2x cubed plus 3x. If we differentiate that, that will give us the gradient. So dy by dx equals 3 times 2x squared plus 3, which gives us 6x squared plus 3. So the thing we have now represents the gradient of the curve, which is constantly changing. We're interested in a particular point in the curve when x equals 2, so we can substitute that in to what we have here. That gives us 6 times 2 squared plus 3, which is 6 times 4 plus 3, which is 24 plus 3, and 24 plus 3 is 27. So the gradient of the tangent at the point we were looking for is 27, and that corresponds to answer B. Question 4. The diagram shows part of the graph of y equals a sine bx plus c. We're then asked which of the lines of the table shows the correct values of a, b and c. So we first of all write down the form of the equation. Y equals a sine bx plus c. So we know it's a sine graph. If we think of the normal sine graph has one cycle which takes 360 degrees. In this graph we can see that one cycle is only 180 degrees. That means in 360 degrees we would fit 2 full cycles, which means that this answer in here for B is 2. What we also notice is that this sine graph begins at 2 on the y-axis. The normal sine graph starts at 0, which means that this graph has been shifted up by 2, which means the value of C is also 2. If we look at this graph, we can see that it has a maximum at 5 and a minimum at -1. That means the total height of the graph is 6. A normal sine graph has a maximum of 1 and a minimum of -1, which means the height of the graph is 2. Our graph has a height of 6, which means it has been multiplied by 3. So our graph has been stretched vertically by 3. That tells us that the value of A is 3. That corresponds to answer D on our table. Question number 5. In this question we are given a recurrence relation where we don't know B. We are given U1 and U2 and we're asked to find the value of U0. So the first thing we're going to do is put down the recurrence relation as it is, which is UN plus 1 equals 1.5 UN minus B. If we write down a recurrence relation with U2 and U1, first of all, then we should be able to work out the value of B. So U2 is equal to 1.5 U1 minus B. We know U2 is 35 equals 1.5 times U1, which is 26, take away B. So that's 35 equals 1.5 times 26. Half of 26 is 13, and 26 and 13 is 39. So that's 39 minus B. If we move B onto the left-hand side and 35 onto the right-hand side, we get B equals 39. Take away 35, and 39 take away 35 gives us B equals 4. So now that we know that B equals 4, we can then write down another recurrence relation with u1 and u0. So u1 equals 1.5 times u0 take away b. So u1 we already know is 26, so that's 26 equals 1.5. u0 take away b, which we now know is 4. If we switch the sides around, what we get is 1.5 u0 minus 4 equals 26. So 1.5 u0 equals 26 plus 4, which means 1.5 u0 equals 30. What that means is that u0 is equal to 30 divided by 1.5. And if we want to work that out without a calculator, we must remove the decimal point on the bottom. We can do this simply by multiplying this by 2, and if we multiply the bottom of the fraction by 2, it's important we do the same to the top. That gives us u0 equals 60 divided by 3, which is much simpler, and 60 divided by 3 is 20. So our answer for u0 is 20, which is answer A. Question number 6. Two functions are defined on suitable domains and are given as f of x equals 3x minus 1 over x and g of x equals x squared plus 6. We are asked to show clearly that g of f of x equals 9x squared plus 1 over x squared. So that's a composite function, and it's the f function, this one here, which is being substituted into the g function. So first of all, we'll write down what both functions are, and we'll give ourselves a little bit of room. So first of all, the f function is f of x equals 3x minus 1 over x, and the g function is g of x equals x squared plus 6. So the composite function that we're trying to find is g of f of x. So that's the f of x function being substituted into the g of x function. So that's this one here being substituted in where we see the x on the g of x function. So a composite function will therefore be equal to not x squared but 3x minus 1 over x squared. Then we have our plus 6. So 3x minus 1 over x all squared is that thing multiplied by itself. So 3x minus 1 over x times 3x minus 1 over x, and not forgetting the plus 6. So what we need to do next is multiply the brackets out. So we'll have 3x from the first bracket multiplying bracket 2, and then minus 1 over x from the first bracket multiplying bracket 2, and then not forgetting the plus 6 at the edge. So 3x times 3x, 3 times 3 is 9, x times x is x squared. Then 3x times 1 over x, well that's like 3 over 1 times 1 over x, so 3x times 1 on the top gives us 3x, and 1 times x in the bottom is x. Similarly with the next one, negative 1 over x times 3x, well that's just like 3x over 1, so 1 times 3x on the top gives you 3x on the top, and x times 1 on the bottom gives you x on the bottom again. Just give ourselves a little bit more room. And then we have negative 1 over x multiplied by negative 1 over x, so that's positive 1 times 1 on the top is 1, and x times x on the bottom is x squared. Then we have our plus 6 at the end. So here we have x on the top and x on the bottom, so those can cancel, and similarly here. So that leaves us with 9x squared, take away 3, plus 1 over x squared plus 6. That then gives us, that then gives us 9x squared minus 3 is minus 6, plus 1 over x squared, then plus 6. The minus 6 and the plus 6 can then cancel, which leaves us with 9x squared plus 1 over x squared. That's what we were trying to show, so that's the end of our proof. Question 7. Triangle ABC has vertices A at 9, 8, B at minus 8, 0, and C at 10, minus 8. Part A asks us to show clearly that the equation of the median through A is 2y minus 3x plus 11 equals 0. So that's this dotted line here. The median passes through point A, and because it is the median, we know that it must pass through the midpoint of the line BC. So to show this equation here, we'll need to determine the equation of this straight line. In order to determine the equation of any straight line, we need to know two things: the gradient of that line and a point on the line. So we'll write that down to remind us what we need. We need m, the gradient of the line, and we need a point on the line. We already know that the line passes through the point A, which is 9, 8. That means all we need to determine now is the gradient of the line. To do that, we're going to use the gradient formula, and in order to use the gradient formula, we need a second point. Fortunately, we know that because the line is the median, it passes through the midpoint of the opposite side BC. So we can determine the midpoint of the side BC by using the midpoint formula. So first of all, we'll write down the 2 points at the end of each line, end of the line, sorry. So B is 8, 0, and C is 10, minus 8. So that's the 2 points at the end of the line that the median meets. The values x1 and y1 and x2 and y2 are the ones we're going to use for our midpoint formula. So m, which is now the midpoint rather than the gradient, is x1 plus x2 over 2, and y1 plus y2 over 2. So substituting in what we have, we know that x1 is negative 8 and x2 is 10 over 2, and y1 is 0 plus y2, which is negative 8 over 2. That means our midpoint is minus 8 plus 10, which is 2 over 2, and 0 plus minus 8, which is 0 minus 8, which is negative 8 over 2. That means our midpoint, m, is 2 over 2, which is 1, and negative 8 over 2, which is negative 4. That gives us a second point on our median line, which we can use to work out the gradient of the line. So A, the point we had already, was 9, 8, and our new midpoint m is 1, minus 4. So this is x1 and y1 and x2 and y2. Substituting into the gradient formula now, so m, the gradient, is y2 minus y1 over x2 minus x1. So that's negative 4, a take away 8, over 1 minus 9. So that then gives us minus 4 take away 8, which is minus 12, over 1 minus 9, which is minus 8. So the minus signs, minus divided by minus, gives us a positive answer, and 12 over 8 can be simplified. 4 goes into both of those, 4 goes into 12 3 times, and 4 goes into 8 twice. So it means the gradient of our median is 3 over 2. So that's what we needed. We needed the gradient along with a point in order to find the equation of the line. So we now know that the gradient is 3 over 2. So we can take these two pieces of information and substitute them into the straight line formula. So we'll write that down over here. Y minus b equals m bracket x minus a. So that's y minus 8 equals the gradient 3 over 2 times x minus 9. Multiplying through by 2 to remove the fraction gives us 2y minus 16 equals 3 bracket x minus 9. So 2y minus 16 equals 3 times x, which is 3x, and 3 times 9, which is 27. Collecting everything to the one side gives us 2y minus 3x minus 16 plus 27 equals 0. That then gives us 2y minus 3x plus 11 equals 0. And this is the equation of the median that we were asked to show. Part B, if we look back at the original question, Part B tells us that the line through C with gradient -2 meets the median through A at the point T. So looking at the diagram, we can see that this line is shown also, this one here. So this line passes through point C, and we're already told that the gradient of this line is -2. The question asks us to establish the coordinates of T, this point here, which is the point of intersection of the median that we have just worked out and this new line. In order to find the point T, we'll need to solve simultaneous equations, which means we will first need to determine the equation of this straight line. Since we know it passes through point C and we're given the gradient is -2, that should make it a fairly straightforward process. So we'll do this over here, writing down the things that we do at the start. Each time we're trying to find a straight line, which is the two things that we need, the gradient and a point. This time the line passes through, the new line is 10, -8, the point C, and we're given the gradient m equals -2. So substituting those in to our straight line formula, that's y minus b equals m bracket x minus a. So that's y take away -8 equals -2 times x minus 10. So that's y plus 8 equals -2 times x, which is -2x, and -2 times -10, which is plus 20. Collecting everything to one side gives us y plus 2x plus 8 minus 20 equals 0, which then gives us y plus 2x minus 12 equals 0. So this is the equation of the new line. We want to establish the point of intersection T with this line and the line we worked out in part A. So what we'll do first is write these two new lines down. So the one we worked out in the part A of the question, the median, was 2y minus 3x plus 11 equals 0. And our new equation is y plus 2x minus 12 equals 0. So we're going to solve these simultaneously in order to find the point of intersection. We can do that if we first put them into the same form and make both equations equal to each other. So to go in that direction, we'll make this one 2y equals -3x moves on to the other side, which makes it 3x, and plus 11 becomes minus 11. The same sort of thing with the other one. We make this one y equals, which means that that becomes minus 2x plus 12. We want to get them in exactly the same form, so we want to multiply the blue one through by 2 to give us 2y equals negative 4x plus 24. They're now both in the form 2y equals, which means both equations must be equal to each other. So that's 3x minus 11 is equal to negative 4x plus 24. In order to solve this new equation, we'll collect the x terms to one side and the numbers to the other. So that gives us 3x plus 4x equals 24 plus 11. That then gives us 3x plus 4x, which is 7x, and 24 plus 11, which is 35. So if 7x equals 35, that means x is 35 divided by 7, which means x equals 5. Now we know our x value of the point t, we need to work out the y value. So we'll take this new x value that we have now worked out and substitute it into one of the original equations. So we'll take the one which is 2y minus 3x plus 11 equals 0. Substituting in x equals 5 gives us 2y minus 3 times 5 plus 11 equals 0. So that's 2y minus 15 plus 11 equals 0, which gives us 2y minus 15 plus 11 is minus 4 equals 0. So 2y equals 4, which then means y equals 4 divided by 2, which is y equals 2. So we now have a y value to go with the x value, which was 5. That now gives us the point of intersection of the two lines, t, which is the point 5, 2, and the end of the question. Question number 8. Given that g of x equals x to the power minus 2 times x cubed minus 1 over x squared, all in brackets, find g dashed of x. So what that means is we need to differentiate. In order to differentiate this, we first must of all prepare it for differentiation. So we'll write down what we have to begin with, which is g of x equals x to the power minus 2, bracket x cubed, take away 1 over x squared. So if we want to prepare this for differentiation, we'll need to remove the brackets first of all. So x to the power minus 2 times x cubed gives us x to the power 1, which is just x, and then x to the power minus 2 multiplied by 1 over x squared. If we think about x to the power minus 2 over 1, then it's top times top, which is x to the power minus 2, and then 1 times x to the power 2, which is x squared. So it's not quite ready for differentiation yet. We have to simplify our second term. So we have x take away, and then we have x to the power minus 2 divided by x squared. So we subtract the powers. Negative 2 take away 2 is negative 4. So what we have now is something that is ready to be differentiated. So our next line is g dashed of x. Differentiate x gives us 1. Then it's take away, and then bring the power minus 4 down to multiply. It gives us minus 4x, and then subtract 1 from the power, gives us minus 5. So that's 1 take away negative 4, which is 1 plus 4 x to the power minus 5. And then leaving our answer as with a positive index gives us 1 plus 4 over x to the power of 5, which is our final answer. Question number 9. A recurrence relation is defined as un plus 1 equals 0.6 un plus 12, with u0, the initial value, equal to 200. Part A asks us to find the limit of the sequence generated by this recurrence relation. So we'll first of all write down what a recurrence relation is again. So it's un plus 1 equals 0.6 un plus 12 and our initial value u0 equals 200. So from our knowledge of reconciliations, we know that that is the value for A and that one is the value for B. And if we want to find a limit of a reconciliation, we use our limit formula, which is B divided by 1 minus A. So that is 12 divided by 1 minus 0.6. So that's 12 divided by 0.4. Now to do that, that's quite tricky. To make it easier for ourselves, we're going to get rid of the decimal by multiplying by 10 on the bottom, which means we must multiply by 10 on the top also. That gives us 120 divided by 4, which is a simpler division. 120 divided by 4 is 30. So the limit of a reconciliation is 30. Part B asks us to find un such that un, take away the limit, is less than or equal to 40. We have now worked out the limit, it's 30, so that means un minus 30 is less than or equal to 40, which means un is less than or equal to 40 plus 30, which means that un is less than or equal to 70. So that means what we're going to do is we're going to actually use our reconciliation now to work out u1 and then u2 and u3 and so on. When we get a value that drops below 70, then the n value that gives us that will be the one that we require. So the first one we can work out is u1, since we are already given u0. So we'll move this up a little bit and set it out. So u1, first of all, is equal to 0.6 multiplied by the initial value u0, which is 200, plus 12. So that's just straight from our reconciliation that we're given at the start. If we do that and work it out on our calculator, we get 132. So our value still hasn't dropped below 70 or equal to 70, so we're not there yet. So we'll now work out u2, which is 0.6 multiplied by the previous value, which is a 132 plus 12, which then gives us 91.2. So we'll continue on. u3 equals 0.6 multiplied by the previous value, 91.2, plus 12, which equals 66.72. So what we notice now is that our value, 66.72, is now less than 70, which is what was asked of us in the question. That means our value for n, the one that we're looking for, is 3. So the answer for part B is n equals 3. Question 10. The curve shown in the diagram, which is not to scale, has the equation y equals ax cubed minus 2x to the power of 4. We're told it has a turning point at A, which is up here, and it cuts the x-axis at B. So it also has another turning point or stationary point here, and that also is another point where it cuts across the x-axis. But we're interested in these two, A and B. So first thing we need to determine is the significance of A and B. A is a turning point, as we have already mentioned, or a stationary point, which makes that significant because the gradient equals 0 at this point. Point B, however, is one of the roots. That's where it cuts the x-axis, and the significance of point B is that we already know the y value is 0. So we'll write that down as a summary of what we already know. So A is a stationary point, which means it has a gradient m equals 0, and B is a root, which means we know that y equals 0 at this point. We'll take each of the points in turn. We'll go with point A first of all. So point A has m equals 0, gradient equals 0. which will allow us to find that point. As soon as we know we are looking for a stationary point, we should know to differentiate the curve. So the original curve is 8x cubed minus 2x to the power of 4. If we differentiate, that gives us the gradient of the curve. So 3 times 8 is 24. X, subtract 1 from the power, makes it 2. And then 4 times 2 is 8. X, and subtract 1 from the power, again that gives us 3. We know that stationary points have a gradient of 0. So this thing here, which represents the gradient of the curve, we can now make equal to 0, because that's what's significant about the stationary point, the gradient 0. What we want to do now is solve for x, which will give us an x value at the stationary point, and we do that by factorising. So the common factor we can take out here is 8x squared. That leaves us with 3 minus x inside the bracket, and that's all equal to 0. So from that we can write down that x squared equals 0, or 3 minus x equals 0. So if 8x squared equals 0, then that means x must be 0. Or if 3 minus x equals 0, that means x could be 3. Point A, if we remember from our diagram, it wasn't at the origin, which means it can't be this point, x equals 0, which means we must be looking at one with x equals 3. So we need point A, which means we need the x and y coordinate, which means we're going to take this x value of 3 and substitute it back into the original curve. So that was y equals 8x cubed minus 2x to the power of 4. So substituting in x equals 3 will give us our y value. So that's 8 times 3 cubed minus 2 times 3 to the power of 4. Move this up to give us space. So that means y equals 8 times 3 cubed. 3 times 3 times 3 is 27. Take away 2 times 3 to the power of 4, which is 3 times 3 times 3 times 3, which is 81. That then gives us y equals 8 times 27, which gives us 216. Take away 2 times 81, which is 162. 216 take away 162 is 54. So that's the y value to go with the x value we have already worked out, which means point A, the one we're looking for, the stationary point was 3, 54. So that's the first part of part A finished. What we need to do now is concentrate on point B. So we'll take a little subheading. Now we're working on point B, and what we know about that point is it's a root, which means that y equals 0. So that fact will help us find our point B. Our original equation for our curve is y equals 8x cubed minus 2x to the power of 4. This time we don't need to differentiate to find point B, since it's a root. We know y is 0, so we'll substitute that into a formula, and that gives us 8x cubed minus 2x to the power of 4 on the other side. To solve any equation at this level, like this, we have to once again factorise. So our common factor this time is 2x cubed. Take that outside the bracket, leaving 4 minus x inside. So that tells us that either 2x cubed equals 0 or 4 minus x equals 0. So for the first one that would mean, and for the second one that would mean that x would be equal to 4. So thinking back to the diagram again, x equals 0 is the point at the origin, the root at the origin, so it's not that one we're looking for. We're looking for the one further along the x-axis, which means we must be looking at this point, the point where x equals 4. So now that we know x equals 4, we already know that it's on the x-axis, which means y equals 0. So that makes point B the point 4, 0. That's the end of part A. Part B in this question asks us to find the angle of theta with the positive direction of the x-axis, and it asks us to calculate the value of theta correct to the nearest degree. So that's this angle here that we're trying to work out. As soon as we see this theta with the positive direction of the x-axis, that should remind us of the formula we need to use, which is m equals tan theta. So we'll do that over here to the side. So the first thing we'll do is write down the formula itself. So m equals tan theta, which means if we are trying to work out the angle theta, we will need to know first of all the gradient of the line. So fortunately in part A we worked out 2 points to allow us to do that. Those points were A, which was 3,54, and B, which was 4, 0. So if we substitute those into the gradient formula, we can work out m. So that's x1 and that's y1. This one's x2 and y2. Our gradient formula, m equals y2 take away y1 over x2 take away x1. So that gives us 0 take away 54 divided by 4 take away 3. Move this up, which then gives us negative 54 over 4 minus 3, which is 1, which means that m equals negative 54. So now that we know m, we can substitute back into the formula m equals tan theta. So we'll write that down again. M equals tan theta. M is negative 54 equals tan theta. And if we write that round the other way, that simply gives us tan theta equals negative 54. So at this point, what we need to do is we need to think about our cast diagram. So we'll jot that down at the side also. We have our all quadrant, our sine, our tan and cos quadrant. Because we have a negative sign here, that tells us that the quadrants we are going to use are the sine and cos quadrants, which means if we do inverse tan of 54, remembering to leave off the negative sign, then we'll get our angle, which is 89 degrees. Now I've rounded that to the nearest degree at this point because the question asks us to work out the size of angle theta to the nearest degree. Now what that means is that theta will equal, first of all, from the sine quadrant, it will be 180 take away 89, which is 91 degrees. And from the cos quadrant, that will be 360 take away 89, which is 271 degrees. Quite clearly, if we look at the diagram, we can see that the angle is an obtuse angle rather than a reflex angle, which means that rules out this one here, 271 degrees, which means our angle theta, the one we're looking for, is 91 degrees. Question 11. The point with coordinates 16, 3 lies on the graph with the equation y equals log x to the base a plus 1. We're asked to find the value of a. So what we're going to do is we're going to substitute our point into our equation. So we know 16 is our x value and 3 is our y value. So we'll write down the equation y equals log x to the base a plus 1, which means 3 equals log 16 to the base a plus 1. Writing that round the other way, we get log 16 to the base a plus 1 equals 3. So that's log 16 to the base a equals 3. Take away 1, which means log 16 to the base a equals 2. Move that up. What we now need to remember is the technique that we've used before, this arrow technique, which tells us that a to the power of 2 is equal to 16. If a to the power of 2, or a squared, equals 16, that then means that a is the square root of 16, and the square root of 16 is 4. Since it's a log, we know the answer is positive. Question number 12. A small open cylindrical glass container has a radius of r centimetres as shown in the diagram. That's the radius there. The total surface area A, expressed in terms of r, is found to be A of r equals 120 divided by r plus pi r squared. Find the radius of the cylinder so that the surface area is at a minimum. Give your answer correct to 2 decimal places. Now this is an optimization question. As far as optimization questions go, this is actually a straightforward one, because often what they ask you to do is to prove or to show this in the first part of the question before we can use it. This one doesn't ask us that, so all we have to do is find r, which gives us our minimum. As soon as we see minimum, we should be thinking of our stationary point, and to find our stationary point we must differentiate to find the gradient. Once we know the gradient, we can then set it equal to 0, because that's the significant thing about stationary points. Their gradient is 0. So the first thing we'll do is we'll write down the formula that we have. So it's A of r equals 120 over r plus pi r squared. So to differentiate this, we first of all must prepare it for differentiation, which means we need to bring the r on the bottom of the fraction onto the top line. So that's 120r to the power minus 1 plus pi r squared. So we now have the formula ready for differentiation. So a dashed of r equals minus 1 multiplied by 120 is minus 120, r to the power, and subtract 1 from the power gives us minus 2, plus, and then 2 times pi r, and subtract 1 from the power once again, and that leaves us with power 1, which is just r. So what we have now represents the gradient. So minus 120 r to the minus 2 plus 2 pi r is our gradient. We are looking for the stationary points, which means the gradient is equal to 0. What we need to do now is solve for r. To do that, we'll first of all bring r to the minus 2 back onto the bottom line to give a positive index, plus 2 pi r equals 0. What we'll do next is take this negative thing onto the other side of the equal sign, which gives us 2 pi r equals plus 120 over r squared. So we're giving ourselves a little bit more room. What we can do now is take the r squared, which is dividing on the right hand side of the equation, onto the left hand side, which means we will multiply, which is 2 pi r times r squared, which is 2 pi r cubed, equals 120, which means r cubed is 120 divided by 2 pi, which means our radius is the cube root of 120 divided by 2 pi. We'll do that on our calculator and correct our answer to 2 decimal places as the question requires, which gives us 2.67 centimetres, the radius of the cylinder. The question asked us to find the radius of the cylinder such that the area was a minimum. Now, we haven't actually shown that yet. We just know that r equals 2.67 is the radius at a stationary point. To show it's a minimum, we will need to use a nature table. So we'll set that out down here. We're going to need the differentiated formula. So I'll put that up here first. A of r equals minus 120 over r squared plus 2 pi r. Now, our nature table will have r, our derivative, which is the gradient, and then an interpretation of the gradient in terms of which way it's sloping. So 2.67 is the stationary point, which means we know the gradient is 0. We need a point before that and one after that for our radius to see which way the line slopes before and after the stationary point. Normally I would choose 0 before, but this time I'm going to choose 1, and the reason for that is we have r squared on the bottom, which it means if we choose 0 we will get something that is undefined. So we'll choose 1 instead to keep things simple. We then need a value higher than 2.67, which we'll make as 3. So I'll give ourselves a little bit of room over at the side here to do that. So substituting first of all 1 into our differentiated formula gives us a dashed of 1 equals minus 120 over 1 squared plus 2 pi times 1. That then gives us minus 120 plus 2 pi, that's a 2 in there, 2 pi. Now, we don't actually need to work that out. We know pi is approximately 3.14, so 2 pi will be double that, which will just be 6 point something. Negative 120 plus 6 point something is definitely negative. So that means we can go back to our table and put that in here. So we have a negative sign. What we need to do now is we need to do the same thing again, but this time with 3. So a dashed of 3 is minus 120 over 3 squared plus 2 pi times 3. So that's minus 120 over 3 squared, which is 9, plus 2 pi times 3, which is 6 pi. So if we work that out, giving ourselves a bit more room again, 120, or rather negative 120 over 9 is negative 13.3 approximately, and 6 times pi gives us 18.8 approximately. So without having to work out the actual answer, we can see that the answer will be positive from this, which means now we can take that back to our nature table and substitute it in. So we have a plus in here. That means our graph is sloping downwards, then it goes flat at the stationary point, and then it slopes back upwards. And we know that that is a minimum turning point. So now we have justified our answer. Our radius is 2.67, which gives the minimum surface area of the cylinder.